Okay, so now what we are going to see, image classification using CNN algorithm. Now CNN stands for convolutional neural network. So we are going to understand the basic concepts of CNN algorithm, how it works. So as I said, initially we started with classification algorithms. Before that we studied the regression algorithms, and the outcome of regression algorithms was some value, some numeric data. And when I talked about the classification problem statement, the outcome was some sort of value. Sorry, some sort of category. That means true or false kind of thing, or some sort of categorical variable, or the class that was the output. That means whether the car is purchased or not purchased. That kind of problem statement we have solved using the classification problem statement. And for that we have seen so many algorithms. Number one, we have seen logistic regression, knn classifier, svm classifier, decision tree, random forest classifier. So many algorithms we have seen, and we have also calculated the performance of each and every algorithm, and that means the confusion metrics and the accuracy score. Also, we have seen how we can use that algorithms for real time data. So if I give real time data input, how this can be solved using all such classification algorithms we have studied in deep. Also, we have seen what to do with the problem is of text classification, for example, SMS spam detection. So in that case, we have seen the NLP libraries and NLP algorithms, NLP pipeline, how to solve the text classification problem, and then bag of words and TF IDF vectorization of our data. Now it's to time to deal with some image classification. Now when I say image classification, it is related to what we say the classification of animals, face recognition, palm recognition, fingerprint recognition, plant leaf disease detection, brain tumor detection, COVID detection using X-ray, CT scan, or anything. It can be any kind of cancer detection, leukemia cancer detection, or any blood cancer detection, or anything can be the problem statement for blur image classification. Sometimes it can be birds classification, identification of birds, animals, identification of crops, or identification of objects. And this is very much useful in case of autonomous car. Now the that is driverless car, which is actually we supposed to drive, or it will be driven automatically. So the car will be having cameras in all different four ways, and that cameras will recognize different objects, and based on that it will give some information to the processing unit inside the car, or the CPU which is sitting inside the car, and according to that the car will be operated, or it is going to be driven. So that will be autonomous car. That's an example of image classification or object detection kind of problem statement. Even we can actually give vision to a blind person using this technique. If the camera is there, and that camera is detecting some object and classifying that object, so and some headphones are connected in the ears of the blind person, then whatever is the scene in front of the blind person can be narrated in terms of some speech output in the ears of that blind person. So that system can tell that blind person that something is in front of you. So that means some people are in front of you, or maybe some trees, birds, whatever the objects are, that can be identified, and that can be recognized, and its speech output or the corresponding audio output can be played inside the ears of that blind person. And this is how the image classification can help the blind person. So there are n number of applications, almost the sky is the limit, and mostly this is the topic under computer vision. So we are providing some sort of vision to the computer, and now the computer will get some eyes through the camera, and now it will recognize the objects in front of the camera. Now that objects can be, let's say, simple. As far as the autonomous car is concerned, it will have to detect some vehicles, road lanes, and some obstacles in front of it. As far as the blind person is there, that blind person will have to identify the objects around him. And if we say that the we can have a book reader, smart book reader also, where that blind person can read the book. So anything can be captured by the camera and that can be processed, and corresponding text can be generated, and that can be a book reading system for the blind people. So as I said, there could be number of applications, and most widely used algorithm is convolutional neural network, or the CNN. And we are going to understand this algorithm in detail. And this is the algorithm of deep learning. So previously we used to talk about machine learning. Now I'm talking about deep learning. So this is the algorithm, and that's the convolutional neural network that will be used for the deep learning purpose. Okay, so let's understand what is convolutional neural network. So it's some sort of neural network. The convolutional neural network is one of the major category to do image recognition and image classification kind of problem statement. And when I say image recognition and image classification, it's all about face recognition, object detection, emotion recognition, brain tumor detection, chronic kidney disease detection using ultrasonic images, and anything can be the application where the images are involved. And this algorithm will take image as input, it will process that image, and finally it will classify under given categories, maybe whether that is the image of the some animal or some bird. Such kind of things can be done using this. So as I said, it's all about the classification of images. It's the algorithm which is used to classify the images, to detect the objects. But now, what exactly the image is? Now, first of all, we need to understand what is the image. And once we understand the image, then only we can understand this algorithm. So as far as images are concerned, images are of three different type. Number one, black and white image. Number two, gray level image. And number three, which is very popular, color image. So towards the right side, the rightmost image is the black and white image. It's having only two colors, black and white, and that's how it is called as binary image also, or the two colored image, or the binary, or the black and white image. That's the rightmost image, having only two colors, either black or white. That's the case. The central image, the image at the center, is again the image of Lena, which is the most popular image in image processing textbooks. And this is actually a model Lena, and her image is used for the image classification, and this for the image processing purpose. And mostly this is the image used for the image processing. And in most of the textbooks of image processing, you will find as an example image this image of model Lena. And now this image is actually a gray level image, which is the image at the center. Though it's look like a black and white image, you may say it's a black and white image only, but not. It's the color image, sorry, color or the gray level image, we can say. It is having 256 number of colors, and it is 8-bit image. So 8-bit, that stands for, it will start from 0 to 255, and that means 0 to 255, that means total 256 colors are there in the image at the center. Now you'll say it looks like black and white. How we can say it's a 256 colored image? So here 0 represent perfect black. Then 1 will be still, it will look like black, but it will be a different shade of grayscale. So it will be a grayscale image, 8-bit image. And as it is 8-bit, so every pixel will be represented by 8 bits. That means 2 raised to 8. That will be 256 number of colors that are possible using this gray level image. And that is the more or information rich version of the model Lena. You can see the rightmost image and the center image. You can find that the information that is carried by the that central image is quite higher than the rightmost image, which is black and white. So as you increase the colors in the image, the information content of that image will increase. After all, image is a data set, or it's kind of some sort of data, and it's some sort of information. So through images we actually exchange data or information. So in our day-to-day conversation, you may see in WhatsApp, Facebook, Twitter, we used to send, or even Instagram, we used to send some messages in the form of some images. So image carries some sort of information, and this is how we exchange information with our friends and family. And the leftmost image is the color image, which is 24-bit image. It is having three different planes: red, green, blue. That's how it is called as RGB. And total number of colors that can be possible are 16 million colors. 16 million different colors can be there in case of a color image. And color image obviously carries the highest amount of information when I compare that with the grayscale image and also with the black and white image. So this time, this color image, which is the again the same model, same person is there in the picture, but now the details are more clear, and the information content of this image is much higher than the two different images, gray level and the black and white image. So this is how the visual representation of image can be, or as we can see this image on the paper, or in the mobile phone, or in the electronic media, or the print media. Okay, so this is how the image will look like, and this is how we will pursue this image as far as the human beings are concerned. But as far as the computer is concerned, inside computer there is no colors, no pens, and there is nothing like ink where the or no paper is there inside the computer. So the computer is going to print everything on that paper, and this is how the computer is going to store the image. So this will not be happening in case of computer. Computer is having the memory, and the memory is either RAM memory or the ROM memory. And every memory stores binary information, or a single bit it will store. Every cell in the memory is going to store a single bit information. So finally, in case of computer, as there is no pen and paper and nothing like colors and painting kind of thing, the image must be represented in terms of some numbers, binary numbers, or some sort of integer kind of numbers. So in case of color image, it will be a three-dimensional matrix. In case of the black and white and grayscale, it will be a two-dimensional matrix. It will be having row and column. But in case of color image, it will be having row plus column plus plane. That means R plane, red, green plane, and blue plane. So that will be a three-dimensional thing. Now let's understand how computer will see your image. This is how the computer will look towards your image. Now let's understand, this is the image. Now at the left hand side I am having some image. This is just an example image, and now I have placed some grid, and every small square represents a pixel. Now this is called as pixel of image. That is the smallest particle inside that image, or the smallest unit in the image. That's the pixel. Now you see here number of pixels are there, and wherever there is white color, the corresponding value in the matrix is 255, and this is the red marked black color. So you see its value is 0, and somewhere these are the gray shades. So you are somewhere you are getting 75, 95, 127, 145. So such kind of values over here, and wherever there is perfect white, there is 255. So in computer, this image will be represented in terms of some pixels. In terms of some pixels will be used to represent this image, and these pixels will be ranging from 0 to 255, where 0 represents the black color, and 255 represents perfect white color. So in this particular case, you can see here, this is the black, perfect black, and that is represented as 0. And somewhere, sometimes we are getting some positive values, and that are, let's say, 95, 75. So these are different grayscale or gray shades. So this will be a matrix. On the right hand side, what we are getting? We are getting a matrix where 0 means black color and 255 means white color. So this kind of matrix can be stored in an computer in the memory. Now it's very clear that image is nothing but matrix, the integer values, and it is the collection of integer numbers. That's what the image is as far as the computer is concerned. Now, in case of grayscale image or the binary image, it will be a two-dimensional array, or this kind of the matrix will be having two dimensions, row and column. But in case of color image, this will be having three dimensions. And now let's understand how the color image will look like. Now, let's say in the previous case, we were having only a single matrix like this, but in case of color image, it will be having three planes: red, green, and blue. You can see here different colors are there: red, green, and blue. So, any color image will be having height, width, and the depth or the dimension, and that will be three-dimensional image. So it will be rows, columns. Now, as you can see here, 6 by 6. Now, six number of rows and six number of columns. That means 36 pixels are there in this image, and every pixel is the having three different value: red, green, and blue. So every pixel will have value, some R, some blue, and some green. So likewise we'll be getting the different values for the image. So this is nothing but the color image. And in case of gray level image, there will be only one plane. As the color image is 24-bit, that means 8 bits of red, 8 bits of green, and 8 bits of blue. So that means 8 plus 8 plus 8. That becomes 24-bit color image. So this is how the computer will store your images. Whenever you will capture a photograph from your camera, and that is stored in your mobile phone's gallery, so this is how it is stored in the memory. And now inside the memory we'll be finding the three-dimensional matrix or two-dimensional matrix, and likewise we'll be getting different images. So now we are in the position that we have understood the different resolutions of images, different types of images, how they will be represented in the computer. That's also we have understood. Now it's time to consider convolutional neural networks that will be used to classify such images, and that's the algorithm that we are going to use. Now we'll understand what is convolution, what is neural network, and what are the different components are there inside the convolutional neural network. Now let's understand this architectural diagram of convolutional neural network. So this is the architecture of convolutional neural network. Now number one thing is that the image. Now this is the image of car that is input to our convolutional neural network. So inside the convolutional neural network, there will be convolution layer, then ReLU activation function, plus there is a pooling layer. Again, there can be a convolution layer, plus ReLU activation function, plus pooling layer. Again, there can be a convolution layer. Again, there can be a ReLU, and again, there can be a pooling. And after that, this can be having multiple layers of it, and then there will be a flattening layer or the flattened layer, and then fully connected neural network, and at the end soft max. So you see here there are six number of different concepts that we are seeing here. Number one is convolution, number two is ReLU, number three is pooling, number four is flattening, number four is fully connected neural network, and number six is the softmax. So the first half, convolution plus ReLU plus pooling, is known as feature learning or the feature extraction stage. And next half, that is flattening layer, fully connected neural network, and the softmax layer, is known as the classification stage of this convolutional neural network. Now, in the previous case, we have seen how we can train our model to find out whether the particular user is going to purchase that car or not. And for that purpose, we have used features. Now, our features were the whatever columns we are having, independent variables are nothing but features. Now, as that was directly in terms of some numbers, so it was very easy to consider those features. Now, what is features? When I say features, what do we mean by features? Basically, if you see, now you are very much trained to identify which is cat and which is dog. Now, whenever you will see a dog on the road, you will immediately identify that this animal is a dog. Now, you may not have seen that dog before. This is for the first time, maybe you are watching that dog, but you have seen so many dogs in the past, so you know that this particular animal is a dog. Now, how you find out that this animal is a dog? Not because of the picture of that dog, but because of the features of that dog. Now, what are features? Now, the color can be the feature, size can be the feature, shape can be the feature, okay, or maybe the sound can be the feature, or the behavior can be the feature. So these are features. So we classify, we identify object based on feature. How we say something is mobile? Based on features, that the mobile phone will have camera, its dimension will be square or the rectangle, it will be having a display, we can make phone calls through it. So these are nothing but features. So the normal human tendency is, we first of all we know the features of a particular object, and based on the features only we classify or we recognize the object. So without knowing the features, we will not be able to recognize the object. And we do not store images in our brain. We store features. For example, if I have to identify cat, so I'm immediately I'm having the features of cat in my mind, that how the cat will speak, what is the size of cat, color of the cat, and the shape of the cat, like that. For example, if something is a cricket ball, how to identify whether this object is a cricket ball? So I will identify that its diameter will be this much, it will be a spherical thing. So based on that I will be identifying that that object is a cricket ball. So this is how we just store features. Similarly, whenever we as a computer, whenever the computer will have to identify some object, it will extract some features from it. First of all, it will not going to store entire images, and then it's not going to match image with image, because if this is going to happen, there can be infinite number of possibilities, infinite number of images that the computer will have to store. And in that case, the memory cannot be infinite practically. For example, if the computer has to identify the whether the particular animal is cat or dog, there can be infinite number of cats, infinite number of dogs in the uh, on the planet. So how can computer store every image? That's not possible. Instead, computer will store the features. It will identify the features, and based on that feature, computer will learn that these are the features of dog and these are the features of cat. So the point is, computer will not store all the images. As in CNN architecture, or even human beings do not store all the images. What we store, features of particular object, only features. Features such as color, size, shape, dimensions, weight, that can be the features. So based on those features we identify the object. Similarly, the first hop of this convolutional neural network is focused on extracting the features from the input image, and once the features are extracted, that will be learned by the computer or the CNN algorithm and the CNN model. And after that the classification will happen. And in case of classification, now whether this object is a car or truck or van, so this can be thing for this particular application. So now we will understand each and everything in detail. What is convolution, what is ReLU, what is pooling, what is flattening, what is fully connected neural network, and what is softmax. Now, number one thing first, convolution layer. Now directly, as we have seen in the previous diagram, image which is to be classified is directly the input to the convolution layer. Now, what convolution layer will do? It will have a convolution with some filter matrix or a kernel matrix. Okay, that is called as kernel matrix or the filter matrix, some sort of filter. It will multiply the input image with some filter matrix. Now, it's not a simple multiplication, it's not the matrix multiplication, it's the convolution. And the convolution is the mathematical operation that is be going to be operated on the image. So this is the image matrix, this big one having the height and width, and d is the dimension of it. And this is the filter matrix having the height fh, filter h, fw, width of that filter, and the depth. So this is the filter matrix, this is the image matrix. So the convolution will happen between this filter and image matrix, and finally we will get the resultant matrix as h minus fh plus 1 and w minus fw plus 1. That will be the dimensions of the resultant matrix. Okay, so this is the convolution operation. So we will have an image. This is the larger matrix is the image, and that will be convolved with this filter matrix, and we'll get this one. Now how convolution works, now let's understand that thing first. Now with the help of this small animation, the convolution is very much clear. Now this is the, on the left hand side, this is the 5 by 5 image matrix. So that means some image is there, let's say image of a car, and that is represented in terms of some numbers or in terms of some metrics by the computer, and this will look like this. And this is the filter matrix. Now we'll say, what is filter matrix? The filter matrix is the standard matrix for convolution operation, and it's all about the as per the algorithm we are using the filter matrix. Now this is the fixed matrix or the constant matrix, and this image is going to change as per whatever image you will apply. Now first of all, how the multiplication will happen. Now first of all, you can see here, or otherwise I'll pause here and then you can find it out what happens to the next iteration. Okay, see here what happens. Now I have paused the simulation. So here, once this filter matrix will be placed on the first side here, and then now it is already placed here and some number is obtained, that is 4. Now it is shifted towards right by one position, and now this 1 into this 1 plus this 1 into 0 plus 0 into 1, 1 into 0, this thing. So 1 into 1, 1, plus this is 1, and this is 1. So 1 plus 1 plus 1, that means 3. So its addition will be taken forward, and that will be 3. So similarly this will be happening. So this is shifted towards right, then multiplied at that area, and their addition of all the numbers is taken, and that is taken forward. This is convolution operation in mathematics. Okay, this is called as convolution of two metrics. And after getting convolution, we'll be getting the features of image. Now whatever we obtain over here, that are nothing but features of input image. Now for human understanding, we stored features like color, shape, size. These could be the features for us. But for computers understanding, from the eyes of convolutional neural network, the features are called as this matrix. This matrix is the feature for the convolutional neural network, and for us the features are color, size, shape, such kind of features we consider. But convolution layer will consider features like this is the convolved feature, and this is known as convolved feature, and which is the result of convolution layer. So after applying the convolution on the input image, immediately we will get the features of image. Okay, what will get the features of image. And then there can be different kernel metrics or the filter metrics. So where is the identity matrix? If it is applied on this image, so we will get the original image back, so there will be no changes in the image if this filter is applied to the input image. If the age detection is applied, so these are some age detection filters, that some terms are negative and we will be getting results. So this, if this is the original image, after edge detection filter or after the convolution with this matrix, we'll be getting like this one. If this is used like this, and if this is used like this, and if you use the sharpen thing, in that case I'll be getting this one. If I use box blur, then I'll be getting this one, and if I use the Gaussian blur, I'll be getting this one. So there are some standard filter metrics available, and based on a particular matrix, which matrix you are using, the result or the convolved image, that means this features. So something like this will get the features. Now these will be the features for the computer or the convolutional neural network. Now once we obtain some features, next step is non-linearity ReLU operation. So where ReLU stands for rectified linear unit, okay, for a non-linear operation. And basically its equation is f of x equal to max of 0 comma x. Now whatever we will obtain, now this is the convolutional feature, that's the result of convolution. Now that will be passed through this activation ReLU function, and the ReLU is nothing but f of x output equal to maximum of 0 into x. Now this is the thing on the left hand side, whatever you are seeing is the thing which is the result of convolution. Let's say it's the result of convolution. So what ReLU is going to do, ReLU is going to convert negative terms to 0. So its basic thing is maximum between 0 and x. Now, if the 0 is maximum, 0 will be passed forward. And if the x is maximum, the x will be go forward. So here 15, first pixel value is 15. So if I compare that with x, sorry, 0, so maximum between 0 and x, maximum between 0 and 15, which is maximum 15. So 15 will go here. Now again the 20 will go. But what is the maximum between 0 and minus 10? Obviously 0 is maximum. So 0 will be here. The 10 will be replaced by the 0. So in simple language, if I have to explain this thing, so its meaning is all negative terms will be converted to 0, and that's the operation, or that's the role of this ReLU operation. So first of all, we will have the convolution of image with the filter, and once the convolution will happen, we will get the features of image, and that features will be passed through this ReLU activation function that will impose some sort of non-linearity in our data, and at the end we'll be getting the result where negative values will be converted to 0 and the positive values will remain as it is. So that's the operation of ReLU. Now next is pooling layer. Now what is pooling? Pooling is used to reduce the number of parameters in the feature or to compress the feature size. Now why to compress? In order to speed up the learning process. As you know, we are going to extract the features from the images, right? So all such features will be first of all, or the first of all, the image will be multiplied with the filter matrix, so that will get, or that will give us the convolutional features, and that features will be again going to face the ReLU operation, and after ReLU we'll be getting non-linearity in our data. That means all the negative terms will be converted to 0 and positive terms will remain as it is. Now such feature can be compressed by using the pooling layer. Now this is very important layer that is actually used to compress the feature, to reduce the feature. Now consider, after having convolution plus ReLU, we are getting this matrix, this center matrix. Okay, this is the larger matrix, 4 by 4 matrix. So pooling layer will, what it will do, it will reduce the dimensions of it. So what it will do, now this is the pink color area. Now there are three types of pooling: max pooling, average pooling, sum pooling. Let's understand max pooling first. So in the pink color area, which is the max value? Obviously the 6 is the maximum value in case of this pink region. So 6 will be taken forward. What is the max value in 2478? Obviously 8 is the maximum, so that will be taken forward. What's the maximum value in 3212? It's 3, so 3 is here, and again 4 is the maximum over here. So this is how the pooling layer is going to compress the feature size, or going to reduce the feature dimension, so that we'll be getting a smaller feature, and after that the definitely the algorithm will work much faster as our features are quite small in size. Now this is the max pooling. What average pooling will do? Average pooling will take average of this thing. So 6 plus 5 plus 1 divided by 4, and whatever will be the value, that will be average value. So this is how the average in that area will be taken forward. In case of max pooling, the max number will be taken forward. And in case of sum pooling, the summation of all the numbers will be taken forward. So this is how the pooling will work. And now interestingly, we have understood three different layers of this: convolution, ReLU plus pooling. Now initially image will be there. Image will be given to convolution layer, where the convolution will happen with image and that filter matrix. So we'll get the features of that image, and once we get the features, the negative features will be converted to 0 using the ReLU layer, and after that there will be a pooling. So pooling is used to compress the size of that feature. Now once we get the compressed features, now it is ready to train the neural network. But here we can again use the convolution layer, ReLU pooling, again one more convolution, ReLU pooling. So depending upon the architecture of your convolutional neural network, or what kind of architecture you propose, you can add a number of convolutional layers, number of ReLU, number of poolings, and there can be a complete chain of it. So for feature learning, you can have multiple convolution, multiple pooling, one after the another. So convolution ReLU pooling, again convolution ReLU pooling, again convolution ReLU pooling. So that can be a multi-stage convolutional neural network. Sometimes up to 18 layers, 16 layers can be there in case of convolutional neural network. So that will discuss later on. But now we have understood what is convolution, what is ReLU, and what is pooling. Now comes the next important step, that is the flattening step, first of all, and then fully connected neural network. So at the end of convolution ReLU pooling, we will get something like this feature 6834. Something like this we will get. Now here comes fully connected neural network, or FC layer, or the FCN, fully connected neural network. So fully connected neural network is all about the neurons and perceptron. So it's having the neurons, and these nodes are called as neurons or the perceptron. And every this neuron or node will have weight plus bias value, and then there will be some inputs. Now, what will be the role of flattening layer? Flattening layer will convert matrix into vector. Now, as you see here, at the end of pooling, we got this two-dimensional matrix 6834. The job of flattening is to convert this matrix into one-dimensional array like x1, x2, x3, x4. So this is the input, and this is the features of our input image. Now, whatever image we have applied, these x1, x2, x3, x4 are nothing but features of our input image. Now, this neural network will have three different layers. Input layer, which is denoted by yellow. Blue color dots are nothing but the middle layer, and this orange is the output layer. So every node you see as the fully connected neural network, it is connected to the next nodes, and every node is connected to all the nodes in the next layer. So this is fully connected. That's how it's called as fully connected neural network. And now these x1, x2, x3, x4 will be there, and that will be applied to this one, and its values will be adjusted. For this, some value will be adjusted. For here again, some values are adjusted. So everywhere the values will be adjusted, and here it is y1, y2, and y3. That will be a outcome of this particular fully connected neural network. So what the training process, how the training and how it will be supervised learning process. So first of all, let's say we need to identify dog and cat. So first of all, we will apply a dog image, and that dog image will go through convolution, then ReLU, and then pooling, and then flattening. So let's say we get x1, x2, x3, x4 for that dog. Now, this network or internal mathematics will be adjusted in such a way that y1 will be maximum and y2 and y3 will be minimum. So whenever I will apply here that dog's image or the features of dog, y1 will be 1 and the y2 will be 0 and y3 will be 0. That's the objective. Okay, and for that purpose the y equals to some mathematical equation x1 plus x2 plus x3. So there will be a complex mathematical equation where the weight and bias value will be there. So for every node, the values will be adjusted in such a way that whenever dog is given as input, so at the end, y1 will be maximum. And whenever cat will be input, y2 will be maximum. And whenever any other animal will be input, y3 will be maximum. In that way, the model will be trained. So first of all, we will apply a dog image. We will get the y1 maximum. If we are not getting y1 maximum, we will adjust, we will make the changes in the values of these nodes. Then again, the dog image will be shown to the network. If the dog is the y1 is maximum, it's okay. Otherwise, again the nodes will be changed. So many images of dogs will be applied to this network, and the job is to make this y1 maximum. Then the image of cat will be applied, and again in that case the y2 will be maximum. Again multiple images will be given, and it will be ensured that whenever the cat's image is appearing to this network, y2 is maximum. And again any other animal will be given as input, and in that case y3 has to be maximum. In that way the internal nodes will be adjusted, and once it is adjusted, that is nothing but fitting process. That is nothing but network fitting. And once the network is trained, once the network is ready, now even if you randomly put any image which is not seen by this network before, unknown image, it will correctly identify whether it is dog or whether it is cat. This is called as training the neural network or the learning of fully connected neural network. Now, as far as the learning is concerned, there are two important approaches are there. Number one is training from the scratch, and number two is transfer learning. Now, in case of training from the scratch, we'll have a data set of so many images. Let's say we need to identify a car, truck, bicycle, so many things we need to identify. So, number of vehicles we need to identify. So, we will be having a data set of our images, and that it will go through convolution layer, then pooling layer, then ReLU, and after that fully connected neural network, and everything will happen just like I have shown in the previous case. And after that the network will train. This is called as training from the scratch or learning from the scratch. Now in case of learning from the scratch, here I need to train our model with new data. So in that particular case, this particular neural network will take time to get it trained. So it will take maximum amount of time to get it trained. Now in case of transfer learning, already a network which is already trained to classify some different things. For example, there is a neural network, convolutional neural network, which is trained to classify on cat and dog, which is ready to classify cat and dog. So we will use that network only because the application is similar. The previously this network is trained to classify cat and dog, and now it is used to classify car and truck. Okay, so ये क्या होता है ट्रांसफर लर्निंग. फॉर एग्जांपल किसी एक बंदे को किसी चीज का एक्सपीरियंस है, ऑलरेडी उसको एक्सपीरियंस है कि एंड्रॉयड ऐप डेवलपमेंट का एक्सपीरियंस है किसी बंदे को. तो उसे पता है कि ऐप कैसे डेवलप किए जाते हैं, ऐप के क्या क्या फीचर्स होते हैं, उसको सब कुछ पता है. लेकिन उसने कभी iOS पे ऐप डेवलपमेंट नहीं किया है. तो क्या होगा कि उसी बंदे को हायर किया जाएगा जो ऑलरेडी ट्रेन है एंड्रॉयड पे. तो उसे थोड़ा सा ट्रेनिंग दिया जाएगा, पूरा ट्रेनिंग तो नहीं देना पड़ेगा, थोड़ा सा ही देना पड़ेगा. तो फिर उसको थोड़ा सा ट्रेन करके फिर वो iOS को भी काम कर सकता है. सो दैट इज नथिंग बट ट्रांसफर लर्निंग का एग्जांपल. उसका जो लर्निंग है, उसका जो टेक्निक है, जो उसने सीखा है किसी और काम के लिए, वही नॉलेज उसका यूज किया जाएगा और थोड़ा सा उसको फाइन ट्यून किया जाएगा अपना नया जो काम है उसके लिए. और लर्निंग फ्रॉम स्क्रैच में क्या होगा कि एक बंदा पूरी तरह से फ्रेशर है, उसने ना तो एंड्रॉयड ऐप डेवलप किया है ना ही iOS डेवलप किया है, तो उसको एंड्रॉयड ऐप डेवलपमेंट करने के लिए ट्रेन करना है. तो उसे पूरा लर्निंग फ्रॉम स्क्रैच करना पड़ेगा, उसको सिखाना पड़ेगा पूरी चीजें. ऐसा नहीं कि उसको सिर्फ रिलेवेंट चीजें सिखानी पड़ेंगी, पूरा ही सिखाना पड़ेगा. तो दैट इज नथिंग बट लर्निंग फ्रॉम स्क्रैच. तो लर्निंग फ्रॉम स्क्रैच में टाइम लगेगा. और ट्रांसफर लर्निंग में क्या होगा कि ऑलरेडी कि जो नेटवर्क ट्रेन है उसी नेटवर्क को हम रेडीमेड यूज करेंगे और उसको फाइन ट्यून करेंगे अपने हिसाब से, अपना नया डेटा देंगे उसको, और उसमें का कुछ थोड़ा बहुत पैरामीटर्स हम चेंज करेंगे. दैट इज नथिंग बट ट्रांसफर लर्निंग. तो अगर कोई नेटवर्क कैट और डॉग आइडेंटिफाई करने के लिए ट्रेन है, तो उसको हम फिर से ट्रेन करेंगे क्या आइडेंटिफाई करने के लिए, कार एंड ट्रक. तो इन दैट वे इट विल आइडेंटिफाइंग whether the particular object is a car or whether the particular object is truck, like that. This is nothing but the transfer learning in machine learning. So next is let's summarize everything. How what exactly we are doing. So in अगर आप previous diagram आप यहाँ पे देखोगे तो उसका पूरा जो flow है वो इस तरह से हमें यहाँ पे समझेंगे कि मुझे ये image जो यहाँ पे है इसको मुझे classify करना है कि ये boat है, house है, tree है या फिर cat है. Whether this is cat, whether this is tree, whether it is house or whether it is boat. Now most probably it's looks like a tree because यहाँ पे tree है तो ये tree का image है. तो पहले हम इसको कन्वोल्यूशन होगा, फिर रेलू होगा, तो फिर उसके पूलिंग होगा, तो हमें छोटा पिक्चर मिलेगा. फिर से कन्वोल्यूशन होगा, फिर से रेलू होगा, फिर से पूलिंग होगा, तो फिर हमें यहाँ पे फीचर्स मिलेंगे. फिर फुल्ली कनेक्टेड न्यूरल नेटवर्क को हम ये सब कुछ देंगे एंड दैट नेटवर्क विल ट्रेन. तो एट द एंड यहाँ पे आउटपुट मिलेगा. बोट का मिला है 0.04, हाउस का मिला है 0.05, ट्री का मिला है 0.9. दैट मीन्स 90% चांस है कि ये जो इमेज है वो ट्री का है. And a cat is 0.01, so that means only 1% chance is there, or 10% we can say is the chance is there that this particular, sorry, 1% chance is there that this particular image is of cat. तो इस तरह से यहाँ पे आउटपुट मिलेंगे। तो हमारा ऑब्जेक्टिव क्या होगा कि हमारे पास ऐसे बहुत सारा डेटा होगा, हमारे पास थाउजेंड्स ऑफ इमेजेस होंगी बोट की, थाउजेंड्स ऑफ इमेजेस होंगी हाउस की, थाउजेंड्स ऑफ इमेजेस होंगी ट्री की, एंड थाउजेंड्स ऑफ इमेजेस होंगी कैट की। तो पहले हम बोट के सारे इमेजेस को देंगे एक के बाद एक। तो यहाँ पे बोट मैक्सिमम आना चाहिए। अगर बोट यहाँ पे मैक्सिमम नहीं आ रहा है, तो हम इसका इंटरनल जो भी मैथमेटिक्स है, वो नोड्स जो है न्यूरल नेटवर्क के, उसका एडजस्टमेंट करेंगे, उसके वैल्यू चेंजेस करेंगे, सो दैट हमें बोट मैक्सिमम मिले। हमने वैल्यू चेंज किया, हम देखेंगे बोट मैक्सिमम आ रहा है क्या, नहीं आ रहा है, फिर से वैल्यू अपडेट करेंगे। तो वो वैल्यू अपडेशन यहाँ पे होगा। फिर उसके बाद फिर से एक के बाद एक बोट के इमेजेस देंगे, और सारे बोट के इमेजेस को हम इंश्योर करने की कोशिश करेंगे कि बोट का जो वेरिएबल है उसका आउटपुट मैक्स आना चाहिए। ये होने के बाद हम हाउस के इमेजेस देंगे, सो मेनी इमेजेस ऑफ हाउसेस, एंड देन अगेन यहाँ पे हाउस का जो आउटपुट है वो मैक्स आना चाहिए। अगर नहीं आ रहा है तो फिर हम वैल्यू चेंज करेंगे। Then for tree will repeat the same thing, and for cat again we will going to repeat the same thing. और ये सब कुछ होने के बाद if we are getting the significant result, that means for house the house output is max, for boat the boat output is max, and so on. In that case we will say our neural network is fully trained. In that case what we will say, our neural network is fully trained. And now वो जो नेटवर्क है वो हम यूज करेंगे किसी भी रियल टाइम प्रोडिक्शन के लिए। ओके, तो एज ए सेट कि इसके लिए हमें डेटा सेट लगेगा। ये जो भी ट्रेनिंग करना है, जो कुछ भी करना है, उसके लिए हमें डेटा सेट लगेगा। तो डेटा सेट कहाँ से आएगा? डेटा सेट के लिए मैंने आपको इनिशियली कुछ वेबसाइट के लिंक बताए थे। तो यहाँ पे देखिए, जैसे कैगल पे ये ब्रेन ट्यूमर का डेटा सेट है, जिसके अंदर दो फोल्डर से, एक नो दैट मीन्स नो ट्यूमर, और इसके एक के अंदर एस दैट मीन्स द ट्यूमर इज देयर। तो ये कैगल पे इस वाले लिंक पे यू विल फाइंड दिस ब्रेन ट्यूमर डेटा सेट। तो इस वाले डेटा सेट को हम लेंगे और इसके ऊपर प्रोसेस करेंगे, और विल ट्राई टू आइडेंटिफाई विच सीटी स्कैन और विच एमआरआई इज हैविंग द ब्रेन ट्यूमर एंड विच इज नॉट हैविंग द ब्रेन ट्यूमर। तो ये सारा चीज हम करने वाले अंडर दिस कंप्यूटर विजन टॉपिक। You will be using OpenCV library and all, or kuch basic image handling we are going to see. Okay, so that we'll consider in the next session. Actual programming and the coding implementation for this we are going to start from the next lecture. And in the next lecture we'll see how the image can be loaded in the computer, how to display that image, how to convert that image to black and white, how to convert that image to grayscale, that's what, or even the thresholding of that image. That's what we are going to understand. We are going to understand basic concepts of image processing and image handling in the Python. And after that, we'll see how the convolution neural network can be used to identify or to detect objects, and how it can be used to classify the images. The problem statement can be brain tumor detection, lung cancer detection, it can be plant leaf disease detection, fruit identification, fruit quality checking, that can be the application, face recognition, that can be application, emotion recognition, that can also be an application, or anything, even the gesture recognition, sign language detection, that can be the application. So leukemia cancer detection, animal recognition, blood cancer detection, any application can be solved. And once you understand the basic concept of this, आप इसके साथ जितने चाहो उतने प्रोजेक्ट कर सकते हो। अगर हमने ब्रेन ट्यूमर का इंप्लीमेंट कर लिया, तो आप लंग कैंसर का इजीली कर पाओगे, आप किडनी का डिसीज के लिए कर पाओगे, आप बर्ड्स आइडेंटिफाई करने के लिए कर पाओगे, आप एनिमल के लिए कर सकते हो, आप फ्रूट्स आइडेंटिफिकेशन के लिए कर सकते हो। सिर्फ एक प्रोजेक्ट इंप्लीमेंट करने की अभी जरूरत है हमें। और जैसे हम एक इसमें प्रोजेक्ट इंप्लीमेंट करेंगे, आप CNN एल्गोरिदम पे, डीप लर्निंग पे बेस्ड इमेज क्लासिफिकेशन का कोई भी प्रोजेक्ट इजीली कर सकते हो। इट कैन बी इमोशन रिकॉग्निशन, फेस रिकॉग्निशन, कुछ भी। सेम स्टेप्स आपको फॉलो करना है। जैसे कि हमने अभी देखा कि लास्ट टाइम हमने कार परचेस की या नहीं, उसके लिए डेटा सेट यूज किया, और उसके लिए हमने मॉडल ट्रेन करके KNN SVM रैंडम फॉरेस्ट डिसीजन ट्री करके किया। तो आप वो हाउस प्राइस प्रिडिक्शन के लिए भी कर सकते हो, स्टॉक प्राइस प्रिडिक्शन के लिए भी कर सकते हो, वाटर रिक्वायरमेंट के लिए भी कर सकते हो। तो उसके बेसिस पे आप कुछ भी कर सकते हो, क्योंकि आपका कॉन्सेप्ट अभी क्लियर हो चुका है। वैसे ही वंस यू अंडरस्टैंड वन प्रोजेक्ट इन दिस, एंड नाउ दिस विल बी द प्रोजेक्ट दैट वी आर गोइंग टू कंसिडर, ब्रेन ट्यूमर डिटेक्शन। एक बार आपने ये कर लिया, तो उसके बाद आप कोई भी प्रोजेक्ट इसमें कर पाओगे वेरी इजीली इन अ फ्यू स्टेप्स। सेम थिंग आपको यूज करनी होगी, सिर्फ आपको डेटा सेट चेंज करना है, एंड सम पैरामीटर चेंज करने होंगे ड्यूरिंग द ट्रेनिंग ऑफ आवर डेटा सेट. दैट्स इट. So for now it's okay. So that's the end for today's session, and we conclude with today's session. But we will wait in the chat. If you're having any queries and doubts, you can put in the chat regarding the today's session.